Okay, Trig kids, this is section 7.3, and I'm going to split it up into two sections, part A and part B. So here we go, section 7.3, part A. Now, for this part A, I am going to work problems 1 through 7. Now, this section, you are definitely going to want to print out the PowerPoint. There's lots of formulas on it. Those formulas are also on that Trig cheat sheet that is in your class drive folder. Again, if you're having trouble accessing that through Google Classroom, I'm not sure what the breakdown is. Make sure you're logged in with your student account. But I also sent the link via Remind, so you can pull it up that way as well. Number 1, I have that sine x equals 8 over 17, and x is in quadrant 1. Now, I'm a picture person, so the first thing I'm going to do is draw a picture in quadrant 1 if sine is 8 over 17, because I'm going to need the rest of them as well. So in quadrant 1, somewhere in quadrant 1, here's my triangle, okay? If this is my x, or my theta, or whatever you want to call it, sine, remember, is opposite over hypotenuse. So that makes this be 8, this 17, and then that means that this side would have to be 15 by Pythagorean's theorem. So what this tells us then is using that same angle of x, I can find cosine and I can find tangent. We're going to need that to find all the double angles. So here we go. This means then that cosine x, remember cosine is adjacent over hypotenuse, is going to be 15 over 17. And tangent of x is going to be opposite over adjacent, or 8 over 15. Now again, we're going to need these double angle formulas. Okay, so let me put the formulas over here quickly. The formulas for sine of 2x is 2 times sine x times cosine x. Okay, that's double angle formula is what they're called. Cosine of 2x. Now cosine of 2x, cosine has 3 different choices. Got 3 different formulas that'll give you the same result. You can do cosine squared x minus sine squared x, or you can do 2 times cosine squared x minus 1, or you can do 1 minus 2 times sine squared x. All 3 of these work for the double angle formula for cosine. Okay, sine only has 1 formula. Cosine has 3. Okay, and then last but not least, we have tangent of 2x is 2 times tangent x over 1 minus tangent squared x. So tangent and sine only have 1 possible formula. Cosine has 3. So, okay, now that we know that sine is 8/17, cosine is 15/17, tangent is 8/15, since it's in quadrant 1, we know that sine, cosine, and tangent are all positive. So now that we know that, let's keep working here. They want us to find sine of 2x. So sine of 2x, I should have put equals here, not colon. We're going to use our formula. Okay, our formula for sine is 2 times sine x times cosine x. So for us, that is 2 times 8/17 times 15/17. So Throw that in a calculator, do the math. I end up with 240 over 289. That would be my answer. Okay, and again, I'm just poking all that in a calculator. So now, cosine of 2x. You can use whatever formula you want. I just used the top one. So the formula was cosine squared x minus sine squared x. Okay, that's the one I used. You could use any of the three. But that gave me 15/17 squared minus 8/17 squared. Again, poke that in a calculator. And I end up with 161 over 289. Okay, 161, 289th. Okay, next one is tangent 2x. Tangent 2x, again, the formula tells us we have 2 times tan x over 1 minus tan squared x. So, for us, that is 2 times 8/15 over, again, let me scroll down and get rid of a couple of dead spots here. 2 times 8/15 over 1 minus 8/15 squared. Again, be careful when you're putting that in a calculator. You're going to need parentheses around the whole bottom since it's more than one term. You poke that in a calculator and you get 240 over 161. Okay, I'm not going to show you the basic arithmetic there. You all can use your calculator effectively, I hope. So that is my problem 1. Okay, so got to know those, well, I should say, got to be able to use those double angle formulas. You certainly don't have to memorize them. I don't have them memorized, but you have to be able to apply them. Okay, so that is problem number 1. Now, moving on to problem number 2. I have, once again, we're going to find sine of 2x, cosine of 2x, and tangent of 2x if tangent x equals negative 15/8 and x is in quadrant 2. Okay, x is in quadrant 2. So, if x is in quadrant 2, remember in quadrant 2, sine is positive, cosine is negative, tangent is negative. Okay, so we have to remember that. So again, if I draw my picture here, okay, here's my terminal side. This is going to be my x degrees or whatever. 15, since tangent is opposite over adjacent, this is like 15 and negative 8 is kind of how I look at it. You can put the 15 on the, or the negative on the 15 or the 8. Visually, I like to put it on the 8 because we went left on the x-axis, but whatever. And then, of course, your hypotenuse. Same type of deal. Your hypotenuse is going to be a 17. Okay? So, once again, my sine here, if I know tangent is negative 15 over 8, my sine of x, remember sine is opposite over hypotenuse, so that is 15/17. My cosine of x is negative 8 over 17. It's adjacent over hypotenuse. So I've got tangent, I've got sine, I've got cosine. Now I can start once again using those double angle formulas. Okay? So sine of 2x. Again, the formula is 2 times sine x times cosine x. So for us, that is 2 times 15/17 times negative 8/17. Poke that all in a handy dandy calculator and you get negative 240 over 289. Okay. Do the same thing with cosine of 2x. Again, cosine of 2x, we can use a different formula if you want this time. Let's use the bottom one. Let's say it's 1 minus 2 times sine squared x. Okay, well that is 1 minus 2 times sine squared. My sine is 15/17 squared. Poke that in a handy dandy calculator and you get negative 161 over 289. Tangent 2x. Again, tangent, we only have one choice for a formula. So we have 2 times tangent x over 1 minus tangent squared x. So for us, that is 2 times negative 15/8 over 1 minus negative 15/8 squared. Now be careful if you're poking all this in a calculator that you're using parentheses correctly. Okay, and again, your denominator is a binomial, so you're going to have to put parentheses around the whole denominator, or you're going to get the wrong answer. So this gives us 240 over 161. Okay, again, sine is negative. Well, sine of 2x, the double angle formula, is negative. Cosine's negative, tangent's positive of the double angle formulas there. Okay, now, problem number 3. Let's take a look. Same type of deal. Still have to find sine of 2x, cosine of 2x, tangent of 2x. But here they start us off a little different. Here they tell us that secant x equals 4 and that x is in quadrant 4. Okay, so secant x equals 4. X is in quadrant 4. Now, if secant x is 4, secant we know is the reciprocal identity of cosine. So this tells us that cosine x equals 1 over 4. Now, in the fourth quadrant, we know, of course, we gave us secant was a positive 4. We know that cosine is also positive in the fourth quadrant. Okay, but in the fourth quadrant, sine and tangent are both negative. Okay, so cosine is the only trig function, cosine and secant, I should say, are the only trig functions that are positive in the fourth quadrant. Okay, so we have to figure out then what sine and tangent are going to give us. So again, if I draw a little picture here, in the fourth quadrant, this would be my angle x here. This would be my triangle. Okay, so if cosine is 1 over 4, then remember cosine is adjacent over hypotenuse. Well, what does that give me then for the second leg in Pythagorean's theorem here? This is going to give me a negative root 15. Negative root 15 is my other leg, and it's negative because of course it's going down. Okay, negative root 15. And again, that's just by Pythagorean's theorem. So that means that sine x, remember sine x is opposite over hypotenuse, so that's negative root 15 over 4. And tangent x, let me sneak it up here. Tangent x, remember, is opposite over adjacent, so that is just negative root 15. It'd be negative root 15 over 1. But, okay, so now let's find our double angles here using our formulas. So sine of 2x, again, formula, is 2 times sine x times cosine x. So that equals 2 times negative root 15 over 4 times positive 1/4. That equals, now your 2 and your 4, one of these are going to cancel. You are going to end up with negative root 15 over 8. Okay? Okay. Now, cosine of 2x. Cosine of 2x. I'm going to use the second formula. I've tried to use a different one each time just to kind of prove to you that they all work. This is 2 times cosine squared x minus 1. So that would give me 2 times 1/4 squared minus 1. Now let me scroll down to get rid of the dead spot here on my board. 1/4. 2 times 1/4 squared minus 1. If you poke that in a calculator, yada, 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 you get negative 7/8. Okay? Now, tangent 2x. Again, our formula is 2 times tan x over 1 minus tan squared x. Okay? So for us, that is 2 times negative root 15 over 1 minus negative root 15 squared. Now, again, remember the square attaches to the parentheses first, okay? So on top here, we would just have negative 2 root 15. On bottom, we would have 1 minus 15, okay? Because you square a negative root 15 and you're just going to get a positive 15, but you still have the minus in front here. This is going to reduce down to root 15 over 7. Okay, that is problem number 3. Now, problem number 4 is kind of ugly, so hang with me, okay? Problem number 4, it says use the formulas for lowering powers to rewrite the expression in terms of the first power of cosine as in example 4. When it says as in example 4, they're talking about in your PowerPoints, okay? The formulas for lowering powers is on slide 11 in your PowerPoint. Okay, slide 11. And then example 4 follows it the next couple of slides. So my problem that they gave me is sine to the 4th of x. Now, I'm going to rewrite this. Hang with me here. I'm going to rewrite this as sine squared of x squared. Now, you all realize that we've been doing this for a while now, but that sine x squared is the same thing as sine squared x. Same exact thing. Okay? So I'm just kind of breaking up the 4th power into squared, squared. Okay? So now I'm going to use some of our formulas here. So the formula that I need, again, if you look on that slide 11, okay, the formula that we need here is for sine. And the formula says that sine squared x equals 1 minus cosine of 2x all over 2. Okay, so I am literally substituting that in place of the sine squared x inside the parentheses. So this is going to equal, I'm going to put it back in blue so it matches here, 1 minus cosine of 2x all over 2 squared. Now, this is a binomial. Don't know if you all kind of realize this, but this we have to FOIL. Okay, what we're FOILing here is 1/2 minus cosine 2x over 2 times 1/2 minus cosine 2x over 2. Okay, that's what we're FOILing. Let me just put those in a box so they're kind of off on their own. So if we FOIL those, remember first, outer, inner, last. If you FOIL those, this is what you end up with. After you FOIL, you have 1/4 minus 1/2 cosine 2x plus 1/4 cosine squared 2x. Maybe I ought to put my parentheses in here as well. Okay, 1/4 minus 1/2 cosine 2x plus 1/4 cosine squared 2x. A cosine 1/4 cosine squared 2x would be multiplying the last times the last. Okay. Now, I have got to substitute this part right here. This cosine squared, I've got to substitute with another formula. Okay. My second formula here is my cosine squared x formula. Again, it's on slide 11 of the PowerPoint, is 1 plus cosine 2x over 2. Okay, so that's my other one. Okay, so sine squared x is 1 minus cosine 2x over 2. Cosine squared x is 1 plus cosine 2x over 2. Those are formulas again on that slide 11 in your PowerPoint. So now I have to substitute that cosine squared here. I have to substitute this in. Okay, so here's what it's going to look like. Hang with me. So we've got 1/4 minus 1/2 cosine 2x plus 1/4, here we go, 1 plus cosine 4x all over 2. Now, let me scroll up. I'm trying to avoid dead spots here. How come in my formula it went up to 4x? Because the original formula here, where you start with an x here, it goes up to 2x there. So here in our problem, we started with a 2x, so it doubles to 4x there. Okay, that's why. So 1/4 minus 1/2 cosine 2x plus 1/4, and then in big fat parentheses, I have the 1 plus cosine 4x. Okay, this is my substitution. This came from there. Okay, now if I distribute that 1/4 power, okay, this 1/4 has to be distributed to that term and that term. So here's what I get out. I end up with 1/4 minus 1/2 cosine 2x plus 1/8. Okay, that's 1/4 times 1/2 plus 1/8 cosine 4x. Okay, so 1/4 times 1/2 is just 1/8, and then 1/4 times the second term is 1/2 times cosine 4x. So 1/4 times 1/2 is 1/8 cosine 4x. Okay, now we have like terms. Okay, these like terms I can combine together. So 1/4 plus 1/8 is going to give me 3/8. So I have 3/8 minus 1/2 cosine 2x, stinking dead spots. Let me see if I can scroll. There we go. Cosine 2x plus 1/8 cosine 4x. Now, I don't know if they will take this. My guess is they probably should. But to me, this would be fine. Or you could also pull out a half, and you would be left with 3/4 minus cosine 2x plus 1/4 cosine 4x. So I would say either one of those would be acceptable for WebAssign. Okay, either one of those, whether you pulled out the 1/2 or not. They're just looking for something common that they could pull out of every term there. Okay, that is number 4. I know it was kind of crazy, but glad you hung with me. Let's do 3 more and then I'll finish out this part A. So let's move on to problem 5. Problem 5, it says use an appropriate half angle formula. Now your half angle formulas, again, are in your PowerPoint. They're on slide 14, or they're also on that Trig cheat sheet, either one. But it says use the appropriate half angle formula to find the exact value of the expression. Now, quickly, let me kind of go over the half angle formulas. So half angle formulas, we have sine of x over 2 equals plus or minus, and it depends whether it's plus or minus as to what quadrant it's in, 1 minus cosine x divided by 2. Okay? Cosine of x over 2, again, is plus or minus the square root of 1 plus cosine x over 2. Now, the tangent of x over 2 is, you got 2 choices here. It's either 1 minus cosine x over sine x, or it's sine x over 1 plus cosine x. Okay, so either one. So those are your half angle formulas. And again, they're on slide 14 in your PowerPoint. They kind of come from those formulas where you are lowering the power. But again, the plus or minus on them depends on what quadrant you're in. Okay, so back to number 5. It says use the appropriate half angle formula to find the exact value of, in this case, cosine 75 degrees. Now, 75 is the same thing as 150 divided by 2. Okay? So, we are going to use the half angle formula. So that means that cosine of 75 degrees is the square root. Now, I put a positive, and well, actually I didn't put it, but I didn't put a negative. It's a positive square root because 75 is in the first quadrant, and the first quadrant cosine is positive. So I don't have to worry about the plus or minus, I just need the plus. So it's the square root of 1 minus, nope, sorry, 1 plus cosine 150 degrees over 2. Okay, 1 plus cosine of 150 degrees over 2. Now, what is cosine of 150 degrees? If you all remember, I need to make my fraction part a little bigger here. 1 plus cosine of 150 is negative root 3 over 2. And that's all over 2. Okay, negative root 3 over 2 is cosine of 150 because 150 is in the second quadrant and the relative angle is 30 degrees. And so negative root 3 over 2. You can look on your unit circle that we have filled out to get that. So if we do a little manipulating here then, okay, this is 2 minus root 3 over 2 all divided by 2. Well, this is 2 minus root 3 over 2 times, if we're dividing by 2, we're multiplying by 1/2, right? So this is 2 minus root 3 over 4, the square root of all of that. This is probably about the only time I'm going to do every step here. Again, let me scroll up to get rid of the dead spots. Now, what's the square root of 4? 2. So I can pull that part out from underneath. So this actually equals 1/2. Now keep in mind that 4 is in the denominator, so it needs to stay when you pull it out. The 2 has to stay in a denominator. So 1/2 times the square root of 2 minus root 3. And I know this looks weird because you've got a radical under a radical, but that is actually how they want you to leave it. Okay? That is actually how they want you to leave it. Or, again, if you don't like it written that way, you could put square root of 2 minus root 3 and put the whole thing over 2. Either way, whether you pull the 1/2 out in front or just pull the 2 out and keep it on the bottom, it doesn't matter. Okay, that's number 5. Number 6. Again, we're using an appropriate half-angle formula to find the exact value of the expression. This one is cosine of 165 degrees. Now again, I want to point out that 165 degrees is the same thing as 330 degrees divided by 2. Okay, so that's what we're going to use in our half-angle formula. So now we have to be careful here because 165 is in the second quadrant. So second quadrant, cosine is negative. Okay, so 165 degrees in the second quadrant, and in the second quadrant cosine is negative. So you'll notice in our formulas we had the little plus minus thing going on. This has got to be the minus. Okay, so now we have minus square root of 1 plus cosine 330 degrees all over 2. Now, 330 degrees, again, gives you a relative angle of 30 degrees, okay? But 30 degrees, 330 is in the fourth quadrant, so when you take the cosine of that, that's going to give you a positive, because remember, cosine is your x-axis, so it's positive in the first and fourth quadrants. So, still have the negative out front here, but we have 1 plus root 3 over 2 all over 2. Okay, and again, same kind of deal as last time. This is going to give me 2 plus root 3 over 2, all of that divided by 2. Okay, which in the long run, again, is going to end up giving me 2 plus root 3 over 4, which is negative square root of 2 plus root 3 over 2. Okay, that is probably how I would write it, or again, you can pull out the 1/2 in the front and then square root of 2 plus root 3. Either way. Okay, you've got to have that negative out there. Okay, that's number 6. One more, and then I'll finish this recording, and then I'll do the second part later. Number 7, again, use appropriate half-angle formulas to find the exact value of the expression. Here we're back to radians. We have tangent of 3 pi over 8. Okay, tangent of 3 pi over 8. Now, let me again kind of go off to the side here. 3 pi over 8 is 3 pi over 4 divided by 2. Because remember, if you divide by 2, you're multiplying by 1/2. So the angle we're actually using then is 3 pi over 4 in our half angle formula. So again, half angle formulas, got to know those. So I'm going to use the first one they gave us. Let me again kind of put this off to the side. Remember that tangent of theta over 2, I don't know why I chose to use theta this time, but 1 minus cosine theta divided by sine theta. That's one of my formulas. That's the one I'll use. Okay. So let's get going on this one. So tangent of 3 pi over 8. Now, first of all, let's talk about 3 pi over 8. 3 pi over 8, where is that? 3 pi over 8 is in the first quadrant. So this is going to be positive. Okay. So tangent of 3 pi over 8 equals, I'm using the formula here, 1 minus cosine of 3 pi over 4 divided by sine of 3 pi over 4. Okay, 1 minus cosine 3 pi over 4 over sine of 3 pi over 4. Now, use your unit circle or whatever to figure this out. Anytime your angle's divided by 4 in radians, you're going to have a 45-degree relative angle. So this is going to be 1 minus a negative root 2 over 2. Now, why is it a negative root 2 over 2? Because 3 pi over 4 is in the second quadrant, and cosine in the second quadrant is negative. So that's why it's a negative root 2 over 2. All over sine of 3 pi over 4 is positive root 2 over 2. Remember, sine is your y-axis, so it's positive in the first and second quadrant. Okay, so on top here, I'm going to have 2 plus root 2 over 2 divided by root 2 over 2. Okay, well, this is, of course, 2 plus root 2 over 2 times 2 over root 2. Well, then I can cancel my 2's out, right? This leaves me with 2 plus root 2 over root 2. Now, you can try that in WebAssign. I don't know that it'll take it because they may want the denominator rationalized, which means, again, we've got to multiply top and bottom by a root 2. So then this gives me 2 root 2 plus 2 over 2. Well, then, of course, these 2's cancel and leave me 1's. So all I am left with then is root 2 plus 1 or 1 plus root 2. I don't care how you write it, it's the same thing. Okay, that is your answer. This is going to finish us up for 7.3 Part A.